All right. Hello, everybody. Welcome back to the stream. Welcome back to the study session. Today is Wednesday, March 12th, 2025, and I hope you're having a wonderful day so far. We are back learning some Python like normal. Oh boy, let me not lie to you guys. I am beat. I stayed up way too late last night finishing CS50X week 9. I'm starting to come down with like a little bit of a cold or something. I'm a little bit like congested, so you know, not a great start, but so today might not be too long. I'm gonna give it my best effort here, but I definitely need to get some sleep tonight. It's been a little bit rough on the sleep schedule lately. We need to do better. Hello, Tim. Welcome back. How you doing? I appreciate you so much for joining me here. How are you doing? Welcome back in. All right. We are continuing on today with Fluent Python. We're going to do about 20, 25 minutes of reading here, and then we will continue on with maybe a leak code problem, and then working on the small business manager project. How about, yeah? If we can get that far. Like I said, I'm pretty beat today. Oh no, Tim, that sounds terrible. Yeah, hopefully not. No super flu, hopefully. Fingers crossed. All right, let's get it going here. All right, so we are unpacking with star functions, in functions, calls, and sequence literals. All right. PEP 448 additional unpacking generalizations introduced more flexible syntax for iterable unpacking, best summarized in What's New in Python 3.5. In function calls, we can use the star multiple times. The star can also def function abc rest, return abc rest. Okay. Fun. One, two, returns one, two, five, six, four, five, seven. Hmm. The star can also be used when defining lists, tuples, or set literals as shown in the examples. So range of 4 unpacks all of the values in a single tuple. Range of 4 list, range of 4 dictionary, or set, range of 4. Unpack the tuple. Okay, so if it's inside of the tuple, it'll unpack then out of it. PEP 448 introduced similar new syntax for star star operator, which we'll see in unpacking mappings on page 80. Hey Koi, what's going on? Welcome back in. Appreciate you so much for joining me again. Welcome back. How's it going? It's been a long time. Appreciate you for joining. Welcome back into the stream. All right, what you guys been studying? Let me know what you guys are working on. Finally, a powerful feature of tuple unpacking is that it works with nested structures. So, nested unpacking. The target of an unpacking can use nestings. ABC inside of a tuple ABCD. ABCD, right? Python will do the right thing if the value has the same nesting structure. Example 2-8 shows nested unpacking in action. So in 2-8 we have metro areas is on the list with these values. Main print f string with this syntax. Okay. Example 1. Each tuple holds a record of 4 fields, the last field of which is a coordinate pair. So 1, 2, 3, 4. Okay? By assigning the last field to a nested tuple, we unpack the coordinates. For name, blank, blank, latitude, longitude in metro areas. If the longitude is less than or equal to 0, print this. Selects only cities in the Western Hemisphere. Gotcha. The target of an unpacking assignment can also be a list. But good use cases are rare. Here's the only one I know of. If you have a database query that returns a single record, the SQL code has a limit 1 clause. Then you can unpack at the same time and make sure there's only one result within the code. So a query returning single row, which is record. If the record only has one field, you can get it directly like this. So just index directly into it. Interesting. Both of these could be written with tuples, but don't forget the syntax quirk that single item tuples must be written with trailing commas. So the first target would be record and the second field. In both cases, you get a silent bug if you forget a comma. Now let's study pattern matching, which supports even more powerful ways to unpack sequences. Hey Wing Hong, welcome in. Welcome back. Koi says it's going great, and last month I found out about machine learning and data scientists. I found about the machine learning data scientists and learning the foundation stuff, and I made a movie recommender system 2 days ago. Nice. That's awesome. You'll have to share that in the project's in the Discord. Okay, so I don't have a lot of notes here. I'll have to come back and get some better notes for these. Right. So pattern matching with sequences. Oh, give me 1 second, you guys. 1 second. All right, we're back. We're back. Okay. Let's see here. Pattern matching with sequences. I'm lacking on the notes here. Let's focus up. Focus up. Okay. The most visible new feature in Python 3.1 is pattern matching with match case statement proposed in PEP 634. Structural pattern matching specification. Python core developer Carol Willing wrote the excellent introduction to pattern matching in the structural pattern matching section of What's New in Python 3.1. You may want to read that quick overview. In this book, I chose to split the coverage of pattern matching over different chapters, depending on the pattern types, pattern matching with mappings on page 81, and pattern matching class instances on page 192. An extended example is pattern matching in list.py, a case study on page 669. Here's a first example of match case handling sequences. Imagine you are a designer. You are designing a robot that accepts commands sent as a sequence of words and numbers like beeper 404 4403. and splitting into parts and parsing them. After splitting into parts and parsing, what is going on? Parsing the numbers, you'd have a message like beeper 40440 and 3 and a list. You could use a method like this to handle such messages. Handle command with a message. Match case. If the case is beeper, if case, quote, is a list with beeper is the command, you do a frequency and number of times, and you call self.beep times frequency. Okay. So these are like commands you're giving to a robot base. Okay, got you. In the case where you have neck as the leading command, an angle, you rotate neck to that angle on a function. On a case of LED, ident intensity, self.led's index ident dot set brightness, ident intensity. In the case of LED, ident red, green, blue, you go into self.leds, into the index of ident, go to set color on that value, ident red, green, blue, the values. And then in the case of everything else, raise invalid command. Okay. Zoom out slightly here. Okay, so in Python, we'll say match and case can be used to match patterns or right. So we'll come here to this guy, shift command 4, take this, switch. You guys want access to these notes? They're in my GitHub in the link down below. Feel free to get access to them there. No, we want to do this one. Copy image. Right. It can be used to match patterns on, right? Mike yesterday hit his 60+ degrees for the first time in 5 months. Oh, Mike yesterday hit 60+ degrees. Right now it's like rainy and stormy for me. It's super rainy right now. Windy. Sure, I am doing it now. Show that in the Discord. It was fun. Using NLP bag of words and cosine similarity. It's basic, but I learned. Nice. Alex then said, I feel like big companies will stop hiring junior engineers altogether in a year or so. What do you think, guys? That's interesting. Tim, I'm done with doomings, Tim says. Yeah. Dooming's kind of getting old. But it's true. Okay, so the expression after the match keyword is the subject. The subject is the data that Python will try to match to the patterns in the case clause. This pattern matches any subject that is a sequence with 3 items. The first item being the string beeper. The second and third item being anything that they will be bound to the variables frequency and times in that order. This matches any subject with the 2 items, the first being, quote, neck. This will match any subject in line in number 3, for first being neck. And number 4, this will match any subject with the first 3 items starting with LED, right, in line 4. And then in line 5, any other sequence or another LED one. And then in line 6, this default is the default case. So I do need to take this. Oh, we're missing this guy. Like so. There we go. I don't know. How I kind of feel about it is, although I don't have any experience in tech, and maybe we'll try to get there this summer and make that jump, but I I feel like the people that have actual passion and desire to code will prevail in the long term. I feel like it'll take a few years to weed out the people that came in here just for the paycheck. Um, because in my opinion, coding, as if you're someone that doesn't like to code, making yourself code for extended amount of time in terms of years, probably uh, you know will burn out. So in my opinion, now it might not be very valid or whatnot, but I think it might take a few years for the people to fade out that weren't supposed that don't actually enjoy coding, um, and the people that actually do enjoy it on a personal level will prevail in the long haul, I think. What do you guys think about that? If you guys are new here, my name is Michael. Thanks so much for joining me. I have a degree in human biology and a minor in chemistry. I'm 26 years old and I graduated back in 2021. I work as a formulation chemist for a biotech company where I make biological controls. I've been doing that for a little over 3 years now since I graduated college. And I'm a scientist too. Been teaching myself how to code and program after my 9 to 5 job every single day for the past 4 months. But I started, a little bit over 7, 8 months ago. But every single day for the past 4 months has been we've been doing that every single day. Thank you guys so much for joining me. Let me know what you guys are working on, what you guys are studying, what your goals are in programming. We can network together here and just learn together. Okay, on the surface, match case may look like a switch case statement from the C language, but that's only half the story. One key improvement of match over switch is destructuring, a more advanced form of unpacking. Destructuring is a new word in Python vocabulary. So destructure, right? Um, it's commonly used in the documentation of languages that support pattern matching like Scala and Elixir. As a first example of destructuring, example 2-10 shows part of example 2-10 shows part of example 2-8 rewritten with match case. Okay, so destructuring nested tuples requires Python greater than 3 point or equal to 3.1. So we have those nested tuples again, right? So we have match, record, case, name this. Okay. So the subject of the word of the match is the record variable, i.e. each of the tuples in the metro areas. In the line 2 here, the case clause has two parts: a pattern, right? This pattern needs to be matched, and an optional guard if keyword. Okay, so you can have if statements in your cases as well. I didn't know that. In general, a sequence pattern matches the subject if the subject is a sequence and the subject and the pattern have the same number of items and the corresponding items matches including nested items. For example, the pattern name blank blank lat long in example 2-10 matches a sequence with 4 items and the last item being a 2-item sequence. Sequence patterns may be written as tuples or lists or any combination of nested tuples and lists, but it makes no difference which syntax you use. In a sequence pattern, square brackets and parentheses mean the same thing. I wrote the pattern as the list with a nested 2 tuples just to avoid with a nested 2 tuple just to avoid repeating brackets or parentheses in example 2-10. Right here. So he did it nested that way within here to show, oh, here. Oh, the example in 2-10 has the repeating brain. Okay, got you. A sequence pattern can match instances of most actual or virtual subclasses of collections.abc.sequence. A sequence pattern can match instances of most actual or virtual subclasses of collections.abc.sequence with the exception of stir, bytes, and byte array. Instances of stir, bytes, and byte array are not handled as sequences in the context of match case. A match subject of one of those types is treated as an atomic value, like the integer 987 is treated as one value, not a sequence of digits. Treating those three types as a sequence could cause bugs due to unintended matches. Got you. If you want to treat an object of those types as a sequence subject, convert it to the match case in the match clause. For example, see tuple phone in the following. Match tuple phone case 1 where the phone number starts with 2 and the rest, and the case where it starts with 3 or 4 the rest. Oh. Okay. Hey, AG, how's it going? I appreciate you so much for joining me. Vanch, welcome back. Welcome back. I appreciate you for joining me here. If you guys are new here, make sure to follow along to the channel. Leave a thumbs up. Let me know what you guys are working on and studying. What you guys are working on. All right. So, what is a good definition for destructuring in Python? Destructuring in Python refers to unpacking values from a data structure like a list, tuple, or dictionary into single variables. It allows you to extract and assign values to multiple values in a single statement. So let's go back up to where it talked about destructuring. A more advanced form of unpacking. A more advanced form of unpacking how is it more advanced than that of unpacking? Destructuring in Python is essentially an advanced form of unpacking because it allows for more complex patterns and flexible ways of extracting data. While basic unpacking assigns values to variables from a list or tuple, destructuring extends that support by nested destructuring by allowing for one nested destructuring, right? You can destructure values from nested structures directly. So I'll take this example here. Right? Like so. Yeah, that works. Okay. Number 2, wildcard for collecting extra values. Um, as a wild card for extra right, so this will be this example here. I like that. There's your wildcard for extra values. Okay, number 3, dictionary destructuring. You can extract specific keys and values from dictionaries. Right. We'll say dot values method. Dict dot values. I guess we'll take it. And we'll just move it below. There we go. If I just do 2, no, you gotta have 3. All right. What leak code are we doing today? I don't know. What do you guys recommend? What's an easy one we can tackle today? All right, got a dip studying for a linear algebra midterm next week. Lots of notes to catch up on. No worries, man. See you later. Thanks for stopping in. Okay, let's keep on pushing. And then number 4, using this with function arguments. Destructing allows you to pass unpacked values into functions. Right, so using to blank to pass unpacked functions. Right, and then we'll give an example here. Right, we'll do this. Here. There we go. Nice. Lead code number 16 looks like a nice warm-up. Okay, we'll keep that in mind. All right. Ignoring values with this. Okay, and then number 5. Ignoring values with right? And then we'll take this, copy. I'll just take this, throw this like so. Okay. Um, right, so I'll say for match case, we'll say stir byte bytes and byte array are not handled as sequences but as atomic values where the value is eval as a single case, a single basis on a singular basis. Right? So I'll take this. Let's see what it says about that. Yeah, exactly. Stir bytes, byte array are technically sequences, but they support indexing and iteration. But Python treats them as atomic in the context of unpacking and deconstructing. They represent a single unified value rather than a structured collection of elements. Attempting to unpack them directly would treat each character or byte as an individual element, which often isn't desired. Hello, this doesn't work. You can't pack. Hi, works for 2. Works for 2 bytes. You can't use star to gather extra values because stir is treated as atomic values. So this, what would this result in? The string hi is iterable and contains 2 characters, h and I. The star A syntax means it will capture all the characters except the last one. The variable B will capture the last character. Result becomes index H in a list containing the first character, and B becomes I, the last character. If the string only has one character, so you can unpack strings. Yes, you can unpack strings because they're iterable, like they're essentially sequences of characters. You can also use the star operator to capture multiple variables in a list. If the number of characters doesn't match the number of variables and no star is used, you'll get a value error. They can still be unpacked with star, but right. Okay. Um, right. So match case. In the standard library, these types are compatible with sequence patterns. List, memory view, array.array, tuple, range, and collections.deg. Um, so we'll go here. I'll say list, memory view, 3, 4, 5, 6. So list, memory view, array to array, tuple, range, collections dot deg. Okay. Compatible with sequence patterns. All right, cool. All right. Keep on trucking here. All right. Unlike unpacking, patterns don't destructure iterables that are not. Unlike unpacking, patterns don't destructure iterables that are not sequences, such as iterators. The underscore symbol is a special in patterns. It matches any single item that is in that position, but it is never bound to the value of that matched item. Also, the underscore is the only variable that can appear more than once in a pattern. You can bind any part of a pattern with a variable using the as keyword. Given the subject, Shanghai, China, 24, Shanghai CN 2419, and a tuple of coordinates, the preceding pattern will match and set the following values to coordinate. Okay, so you can label that as coord. We can make patterns more specific by adding type information. For example, the following pattern matches the same nested sequence structure in the previous example. But the first item must be an instance of stir, and both items in the second tuple must be floats. So it has to be a stir in this first case, in this first item of case check, and then nothing for index 1 and 2, doesn't matter. And then index 3, it has to be a float value. The expressions stir, name, and float lat look like constructor calls, which we use to convert name and lat to stir and float. But in the context of pattern, the syntax performs a runtime type check. The preceding pattern will match a 4-item sequence in which item 0 will be a stir and item 3 will be a pair of floats. Additionally, the stir in item 0 will be bound to the name variable, and the floats in item 3 will be bound to lat and long, respectively. So, although stir name borrows the syntax of the constructor call, the semantics are completely different in the context of pattern matching. Using arbitrary classes in patterns is covered in pattern matching classes on page 192. On the other hand, if we want to match any subject sequence starting with a stir and ending with a nested sequence of 2 floats, we can write case stir, we can take any middle sequence and then capture any two sequences that have floats on the end. Okay. So this is kind of like regular expression almost. The unpacking underscore matches any number of items without binding them to the variable. Using star extra instead of star underscore would bind the items to extra as a list with zero or more items. The optional guard clause causing starting with an if is evaluated only if the pattern matches and can reference variables bound in the pattern as example 210. So match record case this if longitude less than 0, right? The nested block with the print statement runs only if the pattern matches the guard expression is truthy. And the guard expression is truthy. Okay, we'll finish this right here. Deconstructing with patterns is so expressive that sometimes a match with a single case can make code simpler. Guido van Rossum has a collection of match case examples, including one that he titled A Very Deep Iterable and Tight Match with Extraction. Example 2-10 is not an improvement over example 2-8, it's just an example to contrast two ways of doing the same thing. The next example shows how pattern matching contributes to clear, concise, effective code. Hey AJ Brady, welcome in. Appreciate you for joining me. Stream's a little quiet today. That's okay. People must be busy today. School and stuff is busy. All right, let's shift focus here to a Leet code problem. How about, yeah? And then I might call it there. I'm really tired from last night. If you guys don't recall, yesterday we stayed up until 1 a.m. completing the Harvard CS50X week 9, and then so I was up really late last night, and then I'm kind of coming down with a little bit of a cold. Like, I'm a little bit congested and stuff, so I might call it a little earlier. Threesome closest is the one you wanted me to do. I don't know about that one. Longest common prefix. Write a function to find the longest common prefix. They don't have anything in common. So take the first string, evaluate. There's this one here. Longest common prefix. Tim just likes to see me in pain. Tim is he's sick. Okay, so and that they all have to have a common prefix. So we need to have two pointers here basically, right? A two-pointer problem. We need to evaluate the first string, move along the first character. If they're not the same, we break. Else we keep going. I don't know. This one's tricky. Flower flow light. Longest common prefix. How could we go about doing this one? So if we're on the first word with a loop, for word and stirs, for char and word, I'm not sure. Anyone have any ideas how we should go about this one? If we start on the first word, hmm, do we want to go? Do we want to loop through n times, but do it one index character at a time? That won't be very efficient, though. Like, let's say that we start on index 0 of the first word. We then move to index 0 of the second word. We then move to index 0 of the third word. If those are all the same, we save the value in a list. Okay, so what if we say n is equal to the length of stirs for I in the range of n if stirs index I index 0. So we'll say, so that now we have stirs index I is here on flour. We need a counter to access the first variable. So for hmm. So then if we're on the first word, right, we need to evaluate the first character of this word. We then need to say, okay, this character, and this character are all the same. Start over. This character, this character, this character are all the same. Start over. This character. Oh, stop. Return the saved string. So common is equal to an empty stir, and I'll say for I. So we'll say no, yeah. So for I in range of stirs, we want to say, and then for char, for j in range of so we need to get no, so j will start at 0 and just continually go up. So we'll say j equals 0 here. So we say for I in the range of stirs, if stirs index I, the first value in the first iteration, if that index so we go if stirs index I index j Um, okay, so if stirs, so at the first word, if the first character, right? So what do we want to do? We want to, if I is 0, if I is 0, we want to add the character in. So if I is equal to 0, we want to add the character on to common. Um, right? We want to add that on to common, right? If we're not, I equals 0. So after this, right, we want to move I forward and leave J where it's at. So we need to switch then. While searching, we'll set searching equal to false here to begin with. So while searching, true. So while searching for I in the range of stirs, if I equals 0, we're going to add it to common string. And then we need to say, so if we're on flower, F in the flower, we then need to move I over, right? For char in word. Can we say for char in word for word in? So while searching, we're going to be searching for the looping through the values. But that'll be n times 3. 10% memory beats 60%. So maybe we don't need this nested loop. So we want to say for I in the range of stirs, let's say you have a word. You go to the next word, you find out what's common, you keep that. You go to the next word, you find out what's common, you keep that. Okay, so let's try that. So let's go like this. Common equals to a blank string, right? let's say for I in the range of stirs, right, if I is 0, right, so if on the first pass, no, so we're already going to do that. So first off, we want to, no, so if I is 0, if I equals to 0, we want to say common plus equals to stirs index I. Okay, and then now it moves on. Now it goes, okay, so, right, now it moves on. Now it goes to I index 1, which is flow. We want to compare common to flow. For char in stirs index I, for char and stirs index I. So on our first iteration, we're going to add the value, flour, into the comment. We then go past to the next one, and we shrink down our common to whatever is so what if I say split on, what if I do what if I do what if I do this? Common dump equals to stirs index I dot split on quote on common. So if we split on common, that saves the common values, and then we dump basically the right side. Right? So if we have common as flour in our first pass, right, we're going to use split to split off flow and ER, right? Flow will be what we keep, ER is what we dump, we move on. So flour stays. So we say we split on common, common saves, and then we move to flight. We have flow in our common, right? Right, we have flow in our common, and then we split flight. Oh no, we can't split on common here. No, I don't think that'll work. Oh, shoot. So how, if I'm on flour and I save it as my common value and I move to flow, move to flow, I then say, okay, flower and flow, I call so if I call split on that, then it won't do anything. It'll turn false. Let's see here. There's no hint. Straight on to English letters. So I'm trying to what's the desired time complexity of this method? Because I can loop for word in stirs for right. Let the loop go. For So if let's say I'm on the first word flower, which is I index 0. So I will update the first character. So we'll do J is equal to 0. So we'll update the first character of common, right? Else, right? If so stirs index I index J. So we'll take the first word, the first character of that word, and save it as common. So right now we have F in common, right? Then we move on the loop. Okay, next we go to I equals 1. We go to flow. Okay, we say if if stirs index I index, and then we want to leave J where it's not. J is equal to common index J, right? We want to keep going, right? If it's not equal, we want to return empty string. Okay, if it is equal, we want to keep going. So else, if it is equal, right? So the F and the F are equal. We want to J plus equals 1. If it is equal, no, we don't want to increase J here because then it will move to the next letter. We want to run through all of the letters. Oh shoot. Huh. It has to do with prefix. So that's a common suffix, I would assume. Because car would be prefix and a suffix, whereas race car would have a suffix of car. So I don't want to increase j here because I want to continually go through the loop. I want to increase j at the end of the for loop, right? And at the end of the for loop, so if I increase j at the end of the for loop, that will move to the second character after evaluating all of the first character in all of the words in the value in the strs list. Um, so if we get to a word, right? If we get to a word that no longer has a value for j, right? So we can't check j. So if j is equal to the length of strs index I, we're going to return common. So we'll have elif j is equal to the length of strs index I, return common. Okay, so what's going on here? But I need to loop over the words again and again and again until, which won't be very efficient. Anybody have any suggestions? Because am I doing it the wrong way by looking at the first character of every word, then the second character of every word? And then the third character of every word? So while j this is not how you cooked up. I'm definitely on the wrong track here. Let's think. So I just save it as But how can I determine the start at the beginning and see if every character is the same and move forward? I mean, we could unpack the values, but then the value would just be strs. Just be saving a new variable. Python method starts with. I feel like that's cheating. That's like a major hack. just using that Python method that built in. I've never used that method before, but I mean, how would people solve this without Python? It's got to be a different way. How does the starts with function work? That's probably how it's doing it, so let's think. So if we take the first word and we put it up against the second word, for word, so let's say for I in the range length of stirs, for j in the range of I plus 1 to n minus 1. So go up to n. No, we want to go up to n for j. This one would be for n minus 1. Right? We'd say so for I in the range of n minus 1, for j in the range of 1 plus I plus 1 to n, so no, our j counter will be I don't want to have triple loops, like for word in the thing, for word, and then for character in those words. Hmm. Hmm. Should we come back to it? Shoot. Common prefix. Flower, flow, flight. Hmm. Let's come back to it, I guess. I'm not really thinking of anything on top of my head. Yeah, it's considered an easy problem. Hmm. Find the index of a first occurrence in a string. Return that instance. Return the index. Output is 0. It starts on 0. Okay, so we say range. So we need to loop over the entire haystack until we end up on a value. This. So we'll say for I in range of n, and we'll say n is equal to the length of our haystack. N equals the length of haystack. Okay, so for I in the range length of haystack, we're going to loop over all the haystack if haystack index I is equal to needle index I haystack is equal to needle index I index if it's equal to the first value in our needle, what do we want to do? We want to move the haystack pointer forward, right? If it's equal to needle index I, we want to check if m is equal to the length of needle. We want to check for j in range I plus 1 to m. Right? So this will be j will lead 1 greater than I. When we found a value, we'll do a quick loop. Right? For j in the range of I plus 1 to m, which will go to the length of the needle, right? If we're on S and S for haystack and for the needle, we want to loop through I index equals I. Okay. We want to go, shoot. What do we want to say this as? For j in the range of I plus 1 to m, right? If our j leads our I by 1 point, no, so we're getting to a point where we are starting to search for the needle now in our haystack. We found a start potential, right? If haystack, so we'll say j is equal to I plus 1 rather. Say while j is less than m, um, if if haystack index if J haystack index, so we want to look at index want J, if J index J is equal to needle index J, keep going, right? If haystack index J and equals needle index J, we want to pass. If it doesn't, we want to break. If it doesn't, break. So if it doesn't equal here, we break out of this subset check. Else J plus equal 1. So we'll continually increase J forward, and then we'll get to a point where the loop will end, and we need to say if, so we need to basically save found is equal to an empty string. So if we do this, if haystack is equal to this, we're going to say found plus equals haystack index I, right? If we break, right, we want to reset the found equals to this and break, else J plus 1, and then we say after the while loop we say if well, actually, if we don't even need to do that actually, because we can just return back index. We can return back index if J no. So J needs to be set to 0. No, it has to be set to 1 plus I because we need to. This is getting confusing. Hey Hey, Praxis, welcome. Hey, Charlie, how's it going? For the prefix one, you want to iterate through each character, position, string in the array. This string may not be the shortest one, so you need to handle this. For each position, check the same position. Shoot. Feel like I'm down a rabbit hole here too. Today's a bad day for the Leet code. Oh boy. I'm gonna stop the Twitch. I think it's making me lag. Okay. Um okay, so actually for I in the range length of n, we just need to take slices basically. We have length of needle. So we say slice is string slice is equal to um, haystack index I to index m. So that'll give us a string the size of the needle. We'll say if string slice is equal to needle return I, else continue forward. Oh, -1. Man, that was way easier than my first attempt. That just came to me. No way. No way! Okay. Output is -1. Should be 2. Oh, shoot. Return I, else continue. After the loop, if you didn't return anything. Why did I get -1 here? Yeah, this was way easier than my first attempt. Okay, so why did I get -1 here for this edge case? So it should have looped through, got a slice, length of 2. No, length of 2. No, length of 2. Yes, that works. Return back. I. Why didn't that work? So that should fail. This one here, -1. Why am I getting -1 here? Can I run my debug? Oh, I can't. Upgrade to premium to use a debugger? Oh, screw you. Okay, so for I in the range of n, okay, so in this case of hello, I is 0 on H. We're taking a string slice of haystack hello of index 0 through m. So in this case, our length of needle is 2. So we're going 0 to 2. So 0 and 1. We're checking there. If string slice is equal to needle, return I. No, it's not. Okay? Next, move on. Okay, so then here, take a slice. That's not the same. Moves on. Takes a slice here. That's not the same. Or that is the same, so it should return true here. Return I. Hmm. Have you ever tried to implement bubble sort? Not yet. I haven't done that, Don. So, is there a Leet code problem for that one? Mike, you're chefing up now. My exact solution, you nailed it, Mikey. You're cooking with gas now. Sweet, but we're stuck here on this edge case. Why are we turning -1? I don't get it. Anybody know why we're turning 1? The rain. You need I plus M. M would only look at the quote he. Oh, because we need to dynamically. So if I will become greater than at some point M potentially, and so it will no longer be able to take a string slice, and it'll return -1. So we need to have this be I plus M here, so that no matter where I is, it always starts and takes the needle length from I for that slice. There we go. Nice. Woo. Right. Nice. Okay, let's go back. Problems. That was a cool one. We started it down a bad hole, we backed up, and then we got the answer right away. That was good. Okay, I feel a lot better about now, at least a little bit. Now, let's see. Where was the... Uh, so, where was it? Longest common prefix. Okay, so Don Soap says, for the prefix one, you want to iterate through each character position of the first string in the array. Okay, so let's go like this. So he says, for I in range of n, you want to iterate through each character position of the first string in the array. The string may not be the shortest one, so you'll need to handle this. For each position, check that same character position in all other strings. Okay, so we say for I in the range of stirs index 0, so that'll be n. So if we're only iterating over the length of our first stir, right? So I will capture the character. Then we say for word in stirs, right? But we don't need to capture the first word, so we can say for j in the range of m, which m will be the length of just stirs itself. Okay, we don't want to do that we want to do 1 to m, because we don't need to loop over the first string again. We're already capturing that string here. So we'll say if stirs index, so let's just say char equals to stirs index 0 index I, right? So we'll go to the first word in the stir string, get that ith index, and save it as char. Okay. Now this loops over all the other words. So this will say other char is equal to stirs index j index I index j. No. Index j index I. If char is equal to other char, so we'll say if char is equal to other char, right? So if the flour, the F in flour is equal to the F in flow, which it is, we want to move on. We want to move J forward to check for the F in flight. So if it's not equal, right, we're going to just right then and there return an empty string. Potentially. So we're looping through the flour string. We're gaining access to every character in flour. We are then comparing that first character, the F, to the first character, or that I character in every other one, right? So right? So I can already tell that we're gonna have to deal with the length issue. So we're on the F in flour, which saves as char, right? Then we say for J in the range of 1 to M, so this will be flow and flight, will be J. Okay. Other char is equal to stirs index J index I. Okay. If that char is equal to other char, not equal, return blank string. No common prefix here. Else, we're going to just increase J forward until we get all the way through. And we'll save at the end of this for loop, common plus equals to char index to char, right? at the end of this second inner for loop. Now it'll move on to the L. It'll save the L as the char variable. It'll then enter this loop. It'll move to the flower and for J, and then say, okay, flower index 1 for the L, now because I moved up from 0 to 1. Oh, so this would have to be stars, chars. This loops over. This says char index 0. Okay, yeah, so the L in flower. This will good. That's good. So else it'll move, keep moving, and then save. Update the common to include that. At the end of this loop, we're going to return common. So if we need to evaluate though, so if we get to a point where we have flow, we try to evaluate the E and we can't do that on this inner loop for the next value. So if J, no, so if here, try this except index error, right, we're going to return common. Right. So let's try that. Oh my gosh, no way. No way. No way. No freaking way did we just pass both cases first try on that. What? No way. Yo, you guys got to leave a thumbs up for that. What? No way. Yo, Dawn Soap really came clutch with a breakdown. A verbal breakdown. Holy crap, we cooked there. Hold on. Oh my gosh, no way. No way. I was dead stuck on this problem for the first 20 minutes. We left, we solved another one, came back, solved this first try. No way. Hey, Tim, I think I beat your memory complexity. Did you have 60%? No way. Let's go. Woo! 2 Leet codes down today. Feeling good. We were tired. We stayed up till 1 a.m. last night, and we're still solving Leet code. Wow. Wow. I'm amazed. I can't believe we did that. Holy crap. Let's go. I was stuck on this one at the beginning for like 20 minutes. I didn't even have like a solid attempt, and then we reevaled with um so I don't think we need this variable then. Right. Yeah. That might save a little bit of memory. Well, now my memory went way down. Oh well. All right, sweet. Feels good. Leave a thumbs up if you guys enjoyed that one. Where you at, Tim? Where'd you go? Are you here, Tim? No, I can't believe that. I gotta clip that one for the stream. That was fun. That was fun. Look at us. Who would have thought? Two problems down today. Two down. That's a good point too. Let's go back. Dawn Soap says the try catch, right? We say so if you're saying that if I is equal to the length, if I is equal to m, oh, so here you say this. If I is not equal to n, no. If I is equal to the length of stirs index j, right, we return common. Else this other char so if it's equal to the length of stirs index j, meaning that we can't actually index into j using I, then we have to return common at this point in time. Yeah. There we go. There we go, like that. There you go, Don. So you don't check I against the current string you're on, or the first string. You have to check it against the current string you're on, looping past the first one. So you check it stirs j, which would be the second or third string, and the length of that string, and return common there. Yeah. So these are my two solutions. You could do a an if statement here to check for that, or you could do a try except. Right. Try except for an index error. Either one. Sweet. All right, you guys. That was Leet code problems. Which ones did we solve today? Oh, that's right. All right, we solved find the first index of the occurrence in a string, and we solved longest common prefix. Bubble sort can be interesting. Which number is that one, Don Soap? This one? Zero array transformation? Which one's the bubble sort? We should try to take a stab at that one maybe tomorrow. It's just basically comparing the current value to the next value, and if the current value is greater, then you swap them. Yeah. I've done the merge sort problem. That one took me a little bit to understand about how to keep the zero index, the sorted portion, and then as you move that forward from I the I becomes your sorted portion back, and then the J becomes your unsorted portion. Just for funsies? Oh, okay. So basically, bubble sort would be like for I in the range length of the list of numbers. If numbers index I, so it'd be like this for I in the range length of numbers minus 1. If numbers index I is greater than numbers index I plus 1, numbers index I is equal to numbers index I plus 1. And then numbers index I is equal to number I. So and vice versa. You swap them. Yeah, that's how you do it. You'd be like this, right? So let's open up an eco practice here. Be like this. Let's do right. So if you have nums is equal to a list of 3, 6, 1, 2, 4, 9, right? We say for so n is equal to the length of nums for I in the range of n minus 1 if nums index I is greater than nums index I plus 1, right? Nums index I nums index I plus 1 equals nums index I plus 1 nums index I. Print nums here. Oh no. 3, 6. If numbers I is greater than, oh, I think I need to swap these values. Like so. No. Not so fast. Right? Not so fast. For I in the range of, right? If numbers index I is greater than numbers index I plus 1, so if this value is less greater than, do nothing, okay? Right, okay, do nothing, so that, and then it swaps those two. Oh, but wait. You gotta swap it all the way to the bottom, right? So it's doing a swap here, but we're not swapping all the way down. So we need to start from the back. We gotta start from the back. Right, we gotta swap big numbers down all the way to the back. So 9 will swap, 9 will stay, 4 will swap, the 4 will stay, that'll stay, that'll swap. Okay, so actually we need to loop over all of the values, right? We stay here. If we're here, and then for j in the range, while nums index I is greater than nums index j, j is going to be, j is equal to I plus 1, while nums index I is greater than nums index j. So the 3 is not going to be greater than, so it's going to move on. So 1's got to cascade all the way down. That's the thing. If you're getting another loop. Yeah. So for I in the range of n, j is one greater. If so, if I start in the back, I go, okay, here. Okay, those are swap. No, stay, stay, stay. Okay, I'm here. I swap. There, 1 and 6. Swap. Right, because bubble sort is O of n squared. Of n as well. So this is going to be here, this value. So val equals nums index I for j in the range of n if val I plus 1. And so this would go 6. I moves up. So now we need j to loop through every single time, all the way through from the beginning. Right, so val's equal to the, so here, val's equal to the 3. We evaluate, okay, that stays as is. We go here. Okay. So if here is the value, we want to evaluate here one more forward. I. So I guess we do want to do it I plus 1 to n. So then this will go to n minus 1. So then if we're on the 3, we evaluate, is the 3, if value at index I, which is 3, is greater than the value at index j, you want to swap them. Okay, no, it's not. So we need to increase j. If value index I is greater than value, or if value is greater than nums index j, right, then we're going to swap them. value nums j equals to nums j value, right? If it's less than, right, else we're going to increase j by 1, move it forward, and then do the evaluation. That'll swap the 3. Right? So now if I say print nums here, what do I get? Will this throw an irradiant index error? No, that doesn't change anything. I goes, if the value that we're currently on is greater than the right pointer value, then we're going to swap them to. So it's not, so we're going to increase this, okay? Swap. So j will automatically increase. We don't need to increase j then. Whoa, so, right. We don't need to increase. Three, this stays. This first two stays. This one and this one swaps. We have 1, 6, 3. So else, if you make a swap, okay, so if you make a swap, the 1 goes here, the 6 stays here, the 3 goes here. We want to break. Right? But can you break out of a for loop? So should I say while j is less than, so we'll say it look like this. J equals I plus 1 while j is less than n, right? 3, 6, 1, 2, 4, 9. If you make a swap, okay, if you make a swap, you break. Else you keep going. That's why. No, still not. So if you swap the 3 and the 1, 1, 6, 3, no, you don't want to break. You want to keep going. Because then you need to keep going and do some more swaps. So let me go like this. Let me remove this number. Let me variable, let me go nums index I. So I think I'm saving this as a variable. It's overriding that variable, not the actual reference to that numbers index I. Right? No. Oh, shoot. trolling. While J is less than N. Oh, sorry. Trolling. So if you swap, you break. While J is less than N. If numbers index I is greater, you swap them. So this isn't even entering the while loop. Huh. Hey, Robert, Johnny, yeah, we're trying to just implement bubble sort just for practice here. We've never done it before, so just trying to do it for fun. We solved 2 Leet code problems today, and we read out of Fluent Python earlier. So we've done some studying, and now we're just doing some practice for fun before we kind of call it for this evening. Oh yeah, that's right. Because I'm using a while loop now, I have to increment J. So I don't want to break. If I make a swap, so 3 swaps with 1, 1, 6, 3, I then want to keep going with J. So J plus equal, so no matter what, you do J plus equal 1 here. While J is less than N. We can't be equal to N because we don't want to gain an index of N. We have to be 1 less. So we increase J. J is I plus 1. Okay, so let's retry this. So for I in the range of N, and then for, let's go N minus 1, right? No, we'll say for N. Minus 1 for J in range of I plus 1 to N if nums index I is greater than nums index J, right? So if the left pointer is greater than the right pointer, we want to swap them. Right? Right? Else, if they're not, we don't want to do anything. We want to just let it J increase to the next value. So in this first case, 3 and 6, nothing happens, J increases. 3 and 1, we do a swap. Okay. That's still not printing anything. What's going on? Am I like broken? Why isn't this printing anything? What do I have wrong here? I'm stuck in a loop here. That's why. Hold on. So if num's index I. Oh, there you go. Yeah, I was stuck in the previous loop from before. My previous one, I had to just control C out of it. All right, there you go. I solved. It's solved. There must have been an angel by my side. I was like wondering why it wasn't working. It was because why it wasn't printing anything, even like even incorrect stuff, is because we were stuck in that previous loop. We had to just control C out of it. Nice. There's bubble sort. All right, let's throw some extra numbers on there and see. 9, 10, 5, 4, 1, 2, 4, 4, 5, 6, 9, 9, 10. Woohoo! All right. All right, sweet, you guys. For those that are new here, my name is Michael. I'm 26 years old. I have a degree in human biology and a minor in chemistry. I work as a formulation chemist for a biotech company where I make biological controls that are used in diagnostics and testing and clinical and research, and in hospitals and patients. I've been teaching myself how to code for about 7, 8 months now. I've been doing everyday sessions for about 3 or 4. We've improved a lot, but we've got a long ways to go. We are 1 week away from completing Harvard CS50X 2025. We are on the last week, week 10. We'll be watching the week 10 lecture tomorrow. So feel free to join back to watch the week 10 lecture for us. It's only 1 hour long, so it's a really short one. And then after that, it's completely up to us to complete the final project for CS50X and implement some sort of final project and our own original idea. So I think we'll probably have to do some sort of full stack framework where we have a front end that communicates via Flask with a back end in Python, and then we can gather user post requests on pages and do some sort of manipulation via that way. So we could start it off fairly small and then expand forward from there with whatever kind of project we feel. But we'll be working on that probably this weekend. But tomorrow we'll just take a stab at the lecture and watch that tomorrow. Today we read out of Fluent Python. If we read out of Fluent Python, and we did 2 Leet code problems, and then we did a practice here on bubble sort per Don Soap request. Thank you, Don Soap, for your request. That was a great practice, getting some more exposure with bubble sort here. Right, I needed to remember that we had to. I was originally just doing one loop, and it was just doing one pass of the swap. I needed to do a quadratic function here where I swap n squared times, or I do n squared loops to make sure I have all of my loops. I count this number against all other numbers, and so on and so forth, via that quadratic complexity. So that was that. If you know binary trees and stack, you could tackle a binary tree depth first values, to be honest. Yeah, we did the a couple days ago in the Leet code, we did the depth of a binary tree. We did a recursion on that one already. And then I already did the duplicate, remove, find index, group anagrams, length of last word. Let's type in difficulty easy. We'll search difficulty. Right, I did the binary tree longest depth, maximum depth, right? So maybe we could take look at some other binary tree ones, maybe next time. And then I also did the in the Leet code, problem. I did the medium Leet code for making your own stack class implementation. I've already completed that one. All right, you guys. Thanks so much for joining me here. I really, really appreciate you guys that are all here. Today was a little bit more of a quieter stream in terms of turnout, but that's okay. It's about the learning, and I just really appreciate all of you guys that were able to stop in today and hang out with me. Thank you so much. It was a lot of fun doing the Leet code and reading alongside you guys. I stream every single day around 7 p.m. PST, where I stream myself learning and teaching myself computer science, more specifically that of Python. We're going to be diving into more deeper level concepts past CS50X once we complete that course. We're going to be diving into some more math related courses and into some more, operating systems, computer architecture, and hardware related concepts as well. We also are working on independent projects right now, so we're going to make a CS50X final project, but we also have a small business manager project that we've been writing live on the stream. So a lot of content here. I appreciate you guys so much for joining me this evening. I'll see you guys tomorrow. This one's a little bit shorter, 2 hours and 15 minutes. So we did cross over that 2 hour mark, but I did stay up late yesterday until 1 a.m. streaming, finishing week 9 on Flask and CS50X. We streamed for almost 4 or 5 hours yesterday, so that was just a really honestly too long of a stream. I can't really maintain and manage that, especially if I'm going to go every single day. I've got to kind of do shorter ones to at least just stay healthy. So I appreciate you guys joining me here. I'm going to call it a little bit shorter today to get some good rest and come back tomorrow where we'll continue on. I'll see you guys then. Thanks so much for joining me. Join the Discord down below. Um, hey, Jacob Allen, welcome back. Awesome for you to stop in. I'm about to sign off. The tough luck. We completed 2 Leet code problems today, did some reading, and did a bubble sort practice problem as well. So a lot of great stuff going on today. I'll be back tomorrow though, 7 p.m. PST. Please come hang out with me. You don't even have to be working on the stuff I'm working on the stream. Just hang out and just, chat in the chat, but also be working on your own projects on the side or your own homework. Just use the stream as an opportunity to hold yourself accountable and study because I come in every single day. So if you're wanting to allot some time to study yourself on whatever it may be, and you're having difficulty doing that, well, use me as a tool to hold yourself accountable. Load the stream up at 7 p.m. PST for an hour and a half, get your homework done, sign off, and then say, see you later. And, we'll just do that every single day until you graduate or I get into software. So thank you guys so much for being here. I'll see you guys tomorrow. Bye, guys. Thank you.